Excuse me. So, good evening and welcome to this week's BossConstructor development stream. Per usual, we are going to implement the module which has received the most votes this week. And if I remember correctly, that is going to be the tree gun. Let me just double check. Yeah. Suggested by Shredder. Long living and slow projectile spits repeatedly like a fractal. Okay, so this is going to be the base idea for the module. So it's going to spawn a shot which splits into more shots as it matures in a way. And yeah, each segment will do damage. And it's going to have a certain spread and a bit of randomness to it. We are going to make some adjustments to this original idea. First of all, I sort of don't want to call it the tree gun, so I'm thinking more in the lines of fractal gun, or I don't know, like split gun, or I don't know. Okay. So, today we're going to do the fractal gun. This is sort of the preliminary name. We are going to rename it later on, and I guess I can let you guys decide on what name it should get. Alright, so we have to decide on the size. So I'm personally thinking of a 1x3 module, and I think visually it should be like a Tesla coil, because it has sort of this, it's going to have this sort of electricity style effect to it. Maybe we could call it Tesla gun. We'll see. So, per usual, we're going to start by making the module graphics. Then we are going to add it to the game. Then we are going to add functionality and the you know, branching effect. Then we're going to test it. Why is this so full of stuff? Well, test it and deploy it. Okay, I guess we can sort of adapt this as we go along. Alright, so first of all, let's get some inspiration for our graphics. And as implied, I sort of want to make it look like a Tesla coil, which I imagine is just like a coil. Or maybe we could make multiple Tesla coils. So yeah. So disclaimer here, I have no idea about physics, so I don't know what like a real Tesla coil needs and how we should adapt it. But I have to admit, this sort of looks very cool. And yeah, so this is pretty much what I imagine for the effect to look like later on. This is sort of like the lightning effect which we already have, because it sort of links 2 points, for example the coil and the ladder over here, or the basketball basket? I don't know how it's called, over here. And and not that guy standing over there. And yeah, so basically we're going to make a long coily looking module. You already sort of have a bit of a coil for the chain module, so I'm going to use that as the basis for our module. Alright, so let's get started. Let's adapt the color here a bit. Alright. So, if you're watching for the first time, the first step of making module graphics, at least the procedure which I prefer to use, is to make a height map. So basically the brighter a part in this graphic is, the more elevated it is later on, or the more elevated it will look later on. So this is sort of the how do you call it? The workflow, which I've come to quite enjoy. And yeah. So yeah, so I'm still calling it Trigun, but I am actively waiting for an inspiration for a better name. I mean, you can't really call it... Whoops. What did I do? You can't really call it Trigun in a space game. Sort of not. It's not okay. It's not right. Oops. Okay. Next I need sort of a base where the stuff is placed on. So I'm thinking of, yeah, I'm just going to take the fireworks module for this one. So basically this element and this element. Alright. Alright, so let's group it and let's put it on the very base. And let's try to not crash it. Alright. So I found that when you have a lot of these snap-on things activated, it tends to be a little bit on the crashy side. Maybe this is just on my machine, but it's something I definitely noticed, so I'm sort of trying to avoid that. So for some reason this doesn't really align perfectly, which doesn't really make sense, but I guess it will not really be visible later on, so don't need to worry too much about that. Okay. Okay, so basically going to start by making this a very long version of the chain module, and then I'm going to adapt it to differentiate it from the original module. Ah, it's locking up again. So annoying. So it definitely needs to be visible which part of the module is in front and which is not. So there has to be like a visual progression in a way from back to front. Maybe I'm not going to make it 3 by 2. Maybe I'm going to make it 1 by 2. But that's more because I have no clue than like a real gameplay reason. So let's get back to our inspiration source. So if I see this correctly, it's pretty much a round thing on top of a long like cylinder. Okay. Okay. So if I remember correctly, it's sort of like a condensator. Yeah, if you know something about physics, let me know in the in the comments or in the chat. Better said. Okay. So I think this is like it works by creating a really strong current with very little energy actually flowing through it. Yeah, something like that. So these versions actually have sort of a ball from which everything emits, which we could also do actually. Okay, I think we are definitely going to go by one by two. So let me just briefly adapt this. Okay, so I'm going to make it shorter. Then I'm going to adapt this part over here. Whoops. Just putting this part on top. Okay. Then I'm going to delete that stuff. Move everything to the bottom. All right. And then I'm going to remove this part and replace it with sort of a ball-looking thing. Yeah. And then I'm going to add like a little gradient on top, which will make this part be lower from a height map perspective. Okay, so let's create our Tesla end ball, which I'm pretty sure is the correct term for this. I guess the pro move would be to make a gradient here. Okay. Oops, not like this. Not as strong. Maybe a little stronger. So basically, this should be brighter than the backdrop here, because otherwise it would look like it is merging into the background, which it should not. Okay, then I'm going to add the cylinder thing. Or actually we can just use this guy and pull him up. Yeah, actually that sort of looks right. Ready. Okay. So I'm sort of thinking of adding more of these guys. Okay. Oh, I'm sorry. And yeah, so then I'm going to make a duplicate of these guys. Yeah, sort of liking it. Going to make this part a little bit more elevated. Actually I can't, okay. Yeah, that's okay too. Then let's try to make a copy of these guys. Oh yeah, that actually looks sort of nice, I think. Yeah, we could. Yeah, good point. We can make and make a gradient on that guy. Good evening, by the way. Good. What? Okay, yeah, let's do it. I just have to fight against my nemesis, which is the gradient tool of this program. I never quite understand how it's supposed to work. Okay. Okay, I guess it isn't too hard. So. Okay. I think it needs to be a bit brighter here, but not quite as bright as this part. Right. And make that part a bit brighter. Oops. Alright. Then let's copy it and mirror it and move it next to it. Alright. That should sort of work. Just save it at this point. Alright. Finally, I'm going to make a slight gradient on top of these guys to sort of imply sort of a how should I put it? So basically I want to emphasize the fact that this is the part from which the shot actually emits later on. So I'm going to make it look like it's a little bit more flat here and at the back part. Alright, let's make a new gradient. It's actually already almost what we want. It's just wrong way around. And the second part needs to be a bit darker. Alright. And it should be as intense. So let us exit the tool and decrease the opacity a bit. Okay, like 50%. So it's not a super strong effect, but I think it should be visible later on in the graphics. Alright. Actually, let me add a little bit more detail to this. So I'm going to make it look like there's a little bit of a drop down here where the coil is. I think that might give it a little bit of nice detail. So here, 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 and like that, I guess. So let's fill it with something which is just a little bit darker, and let's move it to the right level. All right. I guess it should not really have this part, which also highlights, by the way, that it is not completely symmetrical, unfortunately. Yeah, I guess that's better. Yes, I'm just going to put these guys a little bit more on the outside. Okay, nice. So yeah. Okay, so let's export it. Yeah, name-wise, oops, this is not what I wanted. So I'm just going to, it could be a tree gun, it could be a lightning gun, it could be a Tesla gun, or it could be a, what do you call it? Fractal gun. So if you have more suggestions, please keep them coming. I'm not entirely convinced at all. So, anyway, as usual, I forgot to actually do the exporting. I just named it. Okay, now it should be here. Yep. All right. Looks good so far. Let's apply our usual transformation script. All right. All right. Yeah, I'm actually sort of liking it already. We need to adapt the colors a bit, and we need to create a proper color mask later on. Right. All right. So basically my philosophy is to make weapon modules a little bit darker, a little bit more contrasty. So I'm going to do that here as well. So basically I'm going to make the not this one, this one. Basically I'm going to increase the contrast a bit by making the bright parts even brighter. Yeah, and by pulling down the darker parts a bit like this. Okay, I'm also thinking of making maybe like the lower part a bit darker. I'm not entirely sure yet, but I mean most of the other weapons tend to be darker, so let's take an example like yeah, torpedo launcher, railgun. Or actually not. I mean some of them are, some of them are not. Let's take the fireball as reference. Oops. Okay, actually it is not. Actually I was wrong. Okay, so anyway we need a few more things. We need our usual space overlay, which is just like a texture which we add. A bit more detail. Not entirely convinced. Well, all right, maybe like this. It's actually a bit too dark now, so let's do that part again. So it already has this brightness level, but we need to add a color mask, a proper one. And first of all, we need to save it. Oh, but then again, maybe it is okay. Maybe we even need to increase the brightness a bit. Okay, so actually what I do not quite like about this module is that it is not flat. It is like completely flat here on the outside. So like the fireball module has like a little gradient here on the border. So yeah, I guess I'm going to go back here and edit that. So just make a very simple gradient from black to not so black. Alright, yeah, that should actually do. So yeah, and even one on the bottom maybe. Alright, that should look better, I think. It's interesting how this interacts with the layer over here. Is it good? Is it not good? Let me just check. Yeah, I guess this is better if it's laid on top of it, because otherwise it will sort of interfere with the other gradient. Alright, so let's export it again. And let's try our new one. Yeah, I'm actually liking that a lot more. So I guess we can even pull the shadows down a bit further. And let's have a look again at our reference, the Fireball module. So it should be brighter. Okay. Alright, I guess like this. And we can again add our little bit of detail layer. Alright. And then I'm going to just add a tiny bit of shadow over these parts, I think. Yeah, well, let me try it at least. I'm not sure yet if that's a good idea. But we can try. Okay, so basically I'm just going to paint the parts which I want to be shaded a bit. Not entirely sure if that's a good idea. Basically pull these guys down to like, I don't know, maybe like this. I actually sort of like the idea of having this part a bit darker. Yeah. Maybe even like this, so that it's very clear where the shot is going to emit. Try to blur the mask a bit, maybe 10. Okay, 10 is way too much. Maybe 4. Yeah, okay. Man, maybe not. Maybe 2. Or let's just not do it at all. Alright. Alright. Okay, so let's save it. And next, let's add our color mask. So currently the color mask is pretty small. I guess I'm going to make these parts sort of be the main part which adapts to the player selected color. So the front part will not really change, but the... maybe not? Yeah, I'm guessing that's how I'm going to do it. So let's select some of the parts which we want to change color of. Okay. Alright. And then let's just add these to the color mask. Okay. I think some of the parts should not be active, like these parts, for example. So let's reduce the effect here. Let's reduce the effect over here. Yeah, and I guess reduce the effect here in the middle, because that part seems a little bit excessively bright. All right. So now let's blur it a bit. Perfect. Very nice. Very nice. If I remember correctly, we have to pull that part a little bit down because it is a bit too bright otherwise. So maybe like this. Okay. Good. Good, good. Okay. So let's export this stuff. Tree gun. Tree gun mask. And finally we need a normal map, which we can generate based on the original height map. Okay. This should work pretty fine actually, as a normal map. Okay, nice. Very nice. So, module graphics are sort of done. So next we're going to add it to the game. All right. Okay. Yeah, I'm still going to call it tree gun now, but we are going to give it another name in the localization file, which will be the name that is actually displayed in the game. So, yeah. Okay, let's take the fireball module as a base, save it as tree gun. Yeah, actually for debugging purposes we can leave it like that. So for now it will just behave like a fireball module. And we can go to our localization and just copy the localization text as well. Tree gun name, tree gun description. Tree gun and so on. Actually, we should be more specific at this point because we sort of have to specify what we want the weapon to be before we proceed. So the images, the tree gun is a mid-ranged weapon. It fires in a spread around weapon effective at medium range. Let me briefly illustrate what I intend to do. So let's make an empty graphics. But actually, we can make a little bit a bigger one. Okay, so how is it going to work? So basically, This is our module. It is going to work by I'm sorry actually that some of the dialogues are off screen. I don't really know what causes that. Okay, so basically it's going to fire first single shot. Then after a certain distance, I'm not sure which this distance will be, it has a chance to split into different parts. So for example, at the start it could split into 3 different parts, which will again move a certain distance and then have a chance to split again. Maybe like this, and so on. And both the angle at which they... Let me phrase it differently. The distance, the angle, and the number of splits will depend on the distance. So obviously if these can split 3 times at every branch, that you would get like infinite numbers of elements. So the longer each of these branches has become, the smaller the probability will be that it will actually continue. So in effect you will get something like this. Which looks a little bit like a potted plant, and you should call it a potted plant gun. Alright, and basically each of these branches is going to do damage, and the reason that it has this shape, that there are many branches here in the middle part and few branches at the end and at the beginning, is the reason why this weapon is going to be effective at medium range. Yeah, this is going to be the gameplay effect of it. Yeah, the shot color. We can actually do that. Wait a second. Yeah. Actually, I should totally post this on like Screenshot Saturday as sketch for the new greatest BossConstructor modules. And fruits, yeah. Little cherry over here. Too bad these aren't in-game graphics, but I'm going to totally going to save it. Actually, I am going to treat that. Wait a second. You go. Okay. What else? Okay, so we were here back at weapon effective at medium range. Okay, good. Okay, let's just add it to the German version as well. Well, actually, I'm not going to do that now because... horrible German, but whatever. Okay, so yeah. So now let's compile it and let's find a place where we will add it to the research tree. Research tree, and then we can try it without the later functionality. Yeah. Okay. Good. Good. I actually realized a few days ago that when using a texture atlas, I'm no longer constrained to have order of 2 or power of 2 texture sizes, which was always sort of a given limitation for me. So okay, so research tree. So where should we put it? Well, as usually, we're not going to worry too much about what would make sense, but we're going to just have a very general look at where we could add more stuff. Scattergun, laser, resonance scan. Maybe add it to the laser? That would make a bit of sense, I guess. Energy projection would make sort of sense from a technology perspective, I guess. Energy absorber would also make sense, I guess. Well, I guess I sort of like the idea of having weapons mixed in other parts of the research tree where you don't traditionally have weapons. Okay, so I'm going to add it to the energy absorber. Tree gun, research system. What did I just say? Energy absorber, right? Energy absorber EMP. Okay. Energy absorber tree gun. Right. And let's try it. Pro in Krita. I'm definitely trying. I have actually tried to do a bit of speed painting a long time ago, but it was pretty horrible. Hello, by the way. Okay, so let's make a test chip. Let's make just a copy of our gamma chip, I guess. Tree gun test. I mean, you have to admit, tree gun is very catchy. So, okay, where is it? Okay, here it is. Oh, by the way, do you see the new graphical effects when you add a module? Pretty sweet. Okay. I think it looks a little bit dark compared to the other modules. So let's add a few, for example, the fireball next to it. Okay, it's not that dark actually. So next let's test how it looks when we change the color. Okay. Alright. Looks okay, I guess. And finally, let's just check in-game how the normal maps look like. Okay. Okay, so basically it should, yeah. Currently it still has the fireball effect. Yeah, but the normal maps are working. So you can see the light highlights moving around as we rotate the ship, which is nice. So in retrospect, I don't quite like how the base of the module extends all the way up here. Oh, but I also realized that it resembles the energy absorber quite a bit. It's actually not what I intended. Yeah, but I think there's still a visible difference between them. But there is sort of a resemblance, I admit that. It was not intended. Alright. Alright, adding it to the game is sort of done. Next we are going to add the branching effect. Before I do that, I'm going to take a very brief break and give you some AI battles in the meantime. Which currently showcase like the worst AI bugs ever. Well, yeah. Working on the AI is actually pretty high on my to-do list, so I'm going to do that soon. Okay, so I'm going to back in like 5 minutes, and then I'm going to add the functionality to the tree gun and test it and deploy it to Steam. Okay. worked with Krita some time ago. I also liked it quite a lot, especially for making like drawings with like a Wacom tablet and doing some sketchy stuff. And so, all right. So let's move on. Okay, so how do we do it? So I think we need to implement a function which is not the standard weapon fire effect. This is not going to be so easy, I think. Okay, so let's begin by not worrying about the time dimension at all. So we're going to remove our shot from the world. I'm going to keep the fireball sound effect for now. Yeah, I'm going to add more sound effects to weapons later on, but it's not a priority right now. And yeah, let's make a list called branches. List. And let's make a class called branch. Okay. So branches is a list of branch objects, and each branch has position x and y. It has a rotation, and I guess it's going to have a length, but for now I'm just going to set it to 5. And then I'm going to add a rendering function to the branch, which which function should I use? Let's have a look at the lightning effect class. So maybe we can steal some stuff from here. Segments, render, line segment. Okay, it doesn't quite work like this because, yeah. So instead of having this angle, we need the exact position of the second stuff. Plus we also need the rotation, which is a bit redundant, but the rotation will be important when we spawn more branches from the original one. Yeah, this is Arch Linux actually as an operating system. Okay, AX, AY, BX, BY, and width, I have no idea. So let's start with 3 and see later on what we can take, or we can make. And for now, I'm going to add exactly one branch. Yeah, actually, so maybe I'm going to make this an instant effect. I'm not sure yet. We'll see. So branches. Add branch. And now we are going to add our root branch. I'm not going to. Wait a second. How does it work? I think there is a get point function which you can use. Yeah, there is. Okay, good. Okay, so basically what this getPoint function does is it gives me a point relative to the module which we are currently in. So we are currently in the TreeGun module, so 0 minus 1 should give us the front part of the module, I think. And 0 minus 1 minus 5 should give us a point which is 5 points away from this module. Yeah, I think so. It's probably not going to work correctly right now, but we have to start somewhere. So let's do it. And rotation is going to be the rotation of this module. Okay, so currently we are just making this very first part of our tree, of our potted plant. All right. Branches add root branch, okay. And now, if we render our module, we have to render our branches. Just move that crap to the top. So, for branch B in branches, b.render. That should work. One detail which we need to implement is clear state. Okay, is this guy, clear state, which is basically called when a module is copied. And yeah, it's a very common source for bugs that you clone a module and now two modules share the same list of stuff. So in order to solve that, we have to immediately create a new list of branches whenever we create a new module. Okay, so I think we've done it correctly. I mean, we probably have not, but it's a good starting point to see how it works. You're going to make it a real tree, Corvinus. Could be pretty cool, like with real fruiting in it. Okay, good. Okay, so TreeGun module check, test check. And if we fire, we have 2 lines which are in completely random colors because we did not specify the color yet. But it sort of works. It's a little bit on the dark side. It's also a bit very white, which we should change. Yeah, okay, but otherwise the position is actually correct, which is sort of fortunate. All right. So first of all, let's fix the color. Should be pretty easy. So TL color F. I think it's color F. Is it? no, it's not. So then it is color 4f. Yes, it is. Okay, color 4f, 0.5 plus 0.5 times the red color of our module. And the same for blue and green. And we're going to make it fully opaque, or opaque, however you call it. I'm going to render it, and I'm going to make it a little bit less white. So let's try 1.5. Good. Very good. Now let's start working on the branching part. So I think it sort of makes sense to implement this as a recursive function. It definitely makes sense. I mean, it's sort of the textbook example for making a recursive function. But in that case, I wouldn't use a linked list, and instead use a concurrent linked queue. So in case you don't know, if you use a linked list and you have a loop, like here for example, and you change the list from within the loop, your game will crash. Because linked lists do not allow you to modify their content while you're looking over them. Which makes sense, I guess. So, branch off. Okay. So next we're going to implement a branch off function, and we're going to call this on our root branch. Yeah, correct. Can make your game crash. It depends on which part of the game it occurs in, and what kind of like error like catching you do. Yeah. So in most cases it will not literally crash, but for example the world will no longer be executed and stuff like that. Okay, let's start off very simple, and we're just going to make one single branch. Okay. So we're going to make R is going to be the rotation of our next part, and let's define Cx and Cy, which are going to be bx plus sine or cosine, one of these guys. I think it's cosine here, is it? Well, as usual, it's probably wrong on my first try, so I'm going to have to live with that. Times length, I guess. Okay. And then we're going to create a new branch based on this. And new branch .ax is going to be our bx. Same for y. And new branch bx and y is going to be cx and cy. And the rotation of our new branch is going to be the rotation which we have just used. And then we're going to add it to our list of branches. Yeah, you are correct. It may just cause an exception. Yeah. Okay, let's give it a try. Wait, actually, what would it look like? Okay, since rotation is the same, the next branch element should just shoot off in the exact same direction. Unless unless I mixed up sine and cosine, which I did. So now we have like a swastika design which is completely unintended. Someone's totally going to make like a picture of me making a swastika ship. It's going to be horrible. Maybe it's still wrong actually, so maybe I need to at like a certain angle. I'm not sure. Yeah, it's not correct because here it collapsed back to the position. Okay, so I guess I'm going to leave it as it was, but I'm going to have to add pi over 2 or pi over 3. Pi over 2 or subtract pi over 2 as usual. Yeah, you're correct, Tommy. It's a bit late here as well. Yeah, to be honest, maybe I will change it. I'm not sure yet. I sort of wanted to keep the GMT time the same, and now since we have daylight saving time, it all moved back an hour, which is sort of unfortunate. And to be honest, I completely missed that for like a few streams, so I was constantly streaming an hour early from a GMT perspective. Or an hour late. You can never be sure with daylight saving time. Is it legal in Germany? I have no idea actually. Well, I mean, it wasn't intentional, so it's not like illegal. But you're not allowed to carry swastikas like on your clothing or stuff. I think that's not allowed. Unless you're making like a history documentation or stuff. Okay, so now the second branch part is correct. And we can get to the recursion bit. Okay, so we're going to make a level indicator, which we will increase by 1 for each consecutive branch. So our root branch is going to have a level of 1. And we're going to need that in order to make sure that our tree doesn't grow like infinitely. Next, we are going to... Okay, so new branch level is our current level plus 1. And, and I'm going to make the rotation of our branch a bit random. So I'm going to... I don't know, let's try pi over 4. So we're going to subtract range divided by 2, and we're going to add range times random. Okay, so random is between 0 and 1. And we are subtracting half of the range to get like minus half to plus half. Should be good. And next we can start on our recursion bit. and just add 2 new branches for every branch until we are at a certain level. So we have to sort of cut off this branching process whenever we are at, like, I don't know, level maybe smaller than 8. So how many do we have at level 8? It should be 2 over 8, 2 to the power of 8, which would be 256. Well, we can try. And we can also decrease the length of each segment a bit. Okay. Okay, and we add the new branch. And we have to do the recursive bit where the new branch also does the off-branching stuff. Continue. Yeah, okay. If level is greater than 8, we just stop this process. Yeah, okay. And it's still very possible that I missed something and we're going to get like an infinite loop, but we'll see. And actually, since there's no animation, we really will get like a tree effect. Okay, so potted plant, here we go. Ah, it's beautiful, don't you think? We can always add more trees by firing again. Let me do that again. You. Okay, so what do you like, what do you not like? I do not like that the angle here is so tight in the beginning. So I think there should be a lot more variation here. The trees, they shouldn't just like cut off, but there should be fewer cut-offs later on. I mean fewer branch-offs later on. And I also don't like these like really ugly joints. So we have to do something about that as well. Alright, but basic tree functionality is definitely working here. And I think I might need to increase the range a bit, because I really like how it branches off strongly over here. So maybe going to do like a normally distributed random number. Might look good. Okay, so let's continue. I'm going to make them a little bit thinner first of all, and then I'm going to change the branch count. Okay, so let's make a function called branch count or branch off count, and that branch off count is basically just going to be simple function based on the length. No, based on the level, sorry. So in the beginning we want many, And as we go on, we want less and less. So how about 4 minus level divided by 2? So at around level 8, this would be 0. Okay. And I'm going to remove this cutoff, and instead I'm going to make it like this, branch of count. I mean, later on we can even make the branch of count a bit random. Okay, what else do I want to change? I want to take the range, and instead of having this linear random, like uniform random function, I'm going to make a Gaussian normally distributed function. So in case you don't know, like if these are like plus angle times 2, then the uniform would give you this function, while the normally distributed would give you something like this. So there's a lot more variety, and there is a slight chance of getting like really extreme things, which is very natural and which usually looks very nice. Okay. Okay, so maybe it's a bit too much right now. Yeah, I guess it is. Okay, so let's just decrease it a bit. And also we can try to give it a bit more things like this. Let's go to the extreme a bit. So yeah, you're correct. Actually, we've already created our bush gun, which would be the next great thing, I guess. So I'm really hoping people vote for the bush gun next, because that would save us a lot of work. Yeah, 5 may be a bit overkill. I mean, it's still rendering fluently, which makes me happy, but yeah, it's a bit too bushy. Okay, so let's try 4.5, and let's try level times 0.75. Yeah, and I think next we also need to add a sort of animation effect to it. It will be the next step. Okay, yeah. And another thing which I want is, I want to make the branch of count a bit random. Yeah. So it shouldn't be like totally deterministic. So we're just going to add like a number between -1 and +1 to make it a bit more interesting. Alright. Alright, yeah. Let me test how it looks if you make the individual segments much smaller. So let's halve both the length and the width, and let's multiply the branch of count times 2. Let's just see how that looks. Wait. It will actually spawn way too many things again, I think. Or will it? Yeah, it will if you just divide it, multiply by 2. And we have to divide this part by 2. It's actually sort of hard to get a feeling for how many branches you will get. I mean, obviously you can calculate it, of course, but I think trying it is just as fine, because we'll just find out if it's too many. Oh, actually they're really small now. And also yeah, I would need to increase the branching count. Yeah, but actually I sort of like the previous version much better. I mean, we can still adapt it later on, but actually we can try how it looks if we add a bit more randomness to the branch count. Alright. What else do I want? I do want to sort of connect these line parts. So I'm going to add like a connecting texture. Maybe we'll need another line texture later on. I don't know what we used for the lightning effect actually. Okay, here we used softline 2. Maybe softline 2 is better for this case. Let's try that. And I'm going to make like a connecting segment at this position. Okay, let's try it. It's actually a pretty good idea to use a genetic algorithm to do the tree design. What is it? Okay, rotation. Okay. I mean, we could make it part of the game, so the player can sort of crossbreed different tree modules to get like the tree shape that is best adapted for your ship. There's actually endless possibilities almost to do that sort of stuff. I mean, actually, that would be an interesting game, right? To allow the player to breed his own weapons by crossbreeding different weapons which have different attributes and different behaviors, and to indirectly design the weapon which most appeals to the player. Alright. I think the connecting part did not work at all. Or did it? At least I don't really see it. Oh yeah, because these are two different sizes. Okay, yeah. Let's try that again. We could also experiment with making the branch length a bit random. Okay, yeah, no, that part works, but the texture is totally not what we are looking for, actually. Do I not have, like, a circle texture? I mean, I should have a circle texture, right? Right? Circle. Okay, so why not circle? It may still look pretty bad. This is not going to be easy. It's going to look a little bit better when we wait a second. When we animate it, which we will do soon. Yeah. Okay. Also, let me try to make the tree a bit longer. So I guess we will have to adapt these parameters a bit in order to continue. So let's increase the fall off and let's decrease the base amount to 4. So that should, oops. So that should make the tree a bit longer. I also wanted to experiment with adapting the branch of each, the length of each branch. Okay. So let's just add like a tiny random component and see how that looks later on. Okay, yeah, okay. Okay, next I'm going to make subsequent branches thinner. Okay. So next branch dot width is going to be 1 minus level times 0.1, for example. So the first branch will have width 1 and then it will gradually go down. Okay, and now we have to use this here. Okay, and I think in general I need to make the circle part a bit smaller. So let's try 75%. I like it. I like it. It's tree, it's bushy. You can add multiple bushes and multiple trees. Yeah, it should actually not go to minus width. It is a bit of a bug. Wait, let's try again without bugginess. Yeah, I think the overall angle is a bit too big, so it should be more directed. So that is something we can change, and I will also change that it can have a negative branch. Okay, so basically we only branch off if the branch of the next width of the next branch is greater than 0.1. Alright, and decrease the range a bit. So let's try pi over 12. Okay, so that will pretty much work, so we don't need to test it yet. Instead we can think a bit about how we animate it. Alright. Good. So I'm going to make a variable which I call peak time. And peak time of the first branch is going to be world time, and the peak time of the subsequent branches will be based on that. But it will get a little bit of an increment. So let's try 0.2. And we're going to take the peak time into account when calculating the opacity of our branch here. Okay. Okay, so first I'm going to take the color determination into the rendering function of each branch. And then I'm going to take 1f, which is like 100%, minus the difference between world time and peak time. And I'm going to multiply that by 5, for example. Okay. Oops. So that should give us a basic animation effect where it how can I put it? Where the brightness begins. No, where the first root branch will get bright first, and then the subsequent branches will get lighter, and so on. Let's try it. All right. Okay, so the effect is a bit on the slow side, but I guess you can see where I'm coming from here. And also I want to have other branches still be a bit bright. So now it looks a little bit like a turn-based thing. Okay, so first of all, let's decrease this cutoff thing. Next, let's decrease our peak time increment, and also let's add a little bit of randomness to it. Randomness is always nice with these sort of things, I guess. Okay, so now I guess the effect needs to be a bit more centered. I mean, brightness needs to be a little bit narrower, more narrow. And I guess maybe the time needs to be shorter still, so maybe like 0.75 and multiply it by 4 here. Let's test. Okay, almost done. I think I'm still going to make it even faster, maybe even like 4 or 5 times as fast. Yeah, but other than that, it's pretty much what I want it to be, which is nice. So let's make it 3 times as fast. Let's increase this part to like 15. And then we're going to add the actual damage functionality to the module. I have to say it looks a little bit goofy. I'm not entirely sure why. Maybe I need to change the brightness of the individual segments, or maybe I need to make them a little bit more. Maybe the texture isn't ideal. I think I will still need to improve the look of it later on. I'm also not entirely sure if it looks so good that we have such an impact of the module color on the lighting effect color. So I'm going to turn that down a bit. It seems a bit too strong for my personal taste. That part looked about fine, I think. And we can try the other line texture. Okay, good. Okay, so before we continue working on the graphical effect, let us add the actual functionality to the module. So I'm not quite sure yet if we should make it an instant effect or if the effect should follow the graphical representation of the effect. I mean, the first version would be much easier, I guess. Oh well, not necessarily. Not necessarily. We can just add like an execution function to each branch. Okay, yeah. And then when our module is executed, we just execute each branch. So, yeah, I guess that's sort of the easiest way to do it. Execute, okay, and we'll do several things. So first of all, if world time is greater than peak time plus 1, so in other words, when our individual branch has expired, we are going to remove it. So branches remove this. That's the first thing. And second, and more importantly, we are going to apply the actual damage. So okay, so we have to make sure that the damage is applied only once per branch, and we're going to apply it whenever the world time is greater than the peak time, or greater equal, it doesn't really make a difference, and damage has not been applied. So in that case, we set damage applied to true, and we have to do the actual damage application, which I'm going to steal code for from the laser module. Yeah, I remember this being sort of awkward. And I remember why. Yeah, but we can totally steal code from here. Oh, but it's really awkward. It's really sort of complicated, unfortunately. Yeah, okay, but I guess there's no real way around it. So, okay, so basically, this method uses waycast callback, which is basically a query to the physical world, which then returns back the things which we intersect with. Okay, so I guess I'm just going to have to steal this whole part. Stuff we hit, world raycast, okay. Closest hit. Okay, since this is not a long effect like the laser, we do not really have to check if we hit multiple stuff, so we can make this a bit easier, I think. Okay. Okay, so in order to apply damage, we first need to calculate 2 points, which are the points of the line segment which we test. In this case, just from AX to AY, BX to BY. And then we call the waycast function on this stuff. Okay. Okay. I'm not sure if this reference will work at this level. This is really annoying. I hate that it takes so much code to do this stuff. Damage stuff at position. Okay, we can simplify this part. So instead of returning stuff, we can just process it directly, which is much easier, of course. So RF is reported fixture. I'm really sorry, this part is really not very nice to look at, to be honest. Closest hit is RF, closest hit.WIP, okay. So RF dot WIP. Okay, and damage should be weapon shot damage. This is probably going to be pretty OP at the moment, but we can adapt that later on. Okay. This will probably not compile wide array, but we can take that as a basis. Wow. Okay. So cannot implement. Is abstract does not override. Okay. 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 So we need to return a number, it seems, in order for the interface to work. Alright. What else? Damage position. How do we get the damage position? Okay. How is it done here? Damage stuff at position. Closest hit point. Okay. Hit point dot x, hit point dot y. Okay. So damage position is left dot hit point. Alright. Let's try again. Okay, yeah, so the reference to this at this point did not work. Okay. Reported fixture does also not work. Okay. Okay. Good. Okay, so let's fix the first one. So let's make these a tree. Done. And call it base module. Okay, so root branch base module is this, and whenever we branch off, we propagate the base module, and here we can then return the base module instead of this. Okay, next, reported fixture does not exist, which is here. Okay. Okay, yeah, I guess this is really stupid what I did here. It's actually really stupid. Okay. Okay, so I made this much harder than it needed to be.